Good afternoon, dear participants of the Climate Science Agriculture for Asia 18th TSAE International Conference. In this part, I'm going to talk about the experimental study of apricot dryer using direct and indirect solar dry with natural convection. Let's turn to the introduction. The apricot fruit, is a single seed product of yellow-red color, round in shape, longitudinal grooves, elliptical or ovoid in shape. The apricot kernel is a thick, walnut, smooth, or lumpy. The average weight of the wild apricot is 3 to 18 grams. And the weight of cultivated varieties is up to 80 grams. The weight of 1000 pieces of seed is about 1800 to 2000 2100 gram. Uh, one, 100 grams of apricot product contain on average of 44 kilocalories of energy. Its composition mainly consists of two parts: the wall of fresh fruit, wet fruit pud. The wall of wet fruit pud has pulp and is divided into the three layers, outer and middle. The wet fruit pit is also divided into three parts: the skin, embryon, and endo, the endosperm. The outer layer of the apricot fruit contains protein 0.9 gram, fat 0.1 gram, and carbohydrate 9 grams. And the pulp contains 2.1 gram of dietary fiber and 86.2 grams of water, as well as number of vitamins: pp 0.8 grams milligram, b1 0.03 milligram, v2 0.06 milligram, A is 0.267 milligram, C 10 milligram, AE is 1.1 milligram, and niacin is a 0.7 milligram. Beta carotene is a 1 milligram. The outer and the middle layer of apricot contain the following chemical element: glucose 2200 milligram, fructose 800 milligram, phosphorus 26 milligram, magnesium 8 milligram, potassium 305 grams, calcium 28 milligram, iron 0.7 grams, and sodium 3 milligrams. And material method: fresh apricot Navi variety were selected for experiment, 32.209 kilogram. The fruit had an average size 36, 33, 31 millimeter, and the weight from the 24 to 27 gram. Their initial moisture content was approximately 86% measured using laboratory moisture analyzer. Before drying, apricot were washed, halved, and pits were removed. During the drying process of apricot, the first things that evaporates water from the outer layer of the pulp. The evaporation of the water vapor from the middle and inner layers is difficult, since the temperature of the parts of the water that evaporates before transferring heat to the middle and inner layer increases. This situation leads to the rupture of biological fibers in the outer layer and the loss of their previous properties. The fully preserve the quality of the dried products. They should be stored in the drying device with direct solar radiation and natural air convection until the water in the outer layer evaporates, and then in direct solar dry with natural air convection. The dryer may be suitable for this target until equilibrium moisture content is achieved. Drying system. In this study, two drying systems were evaluated: a direct solar dry with a natural convection, and indirect solar dry with a natural convection. For comparison, open air sun dryer was also conducted as a control group. The indirect solar dryer includes a storage cabinet containing silica gel to control the humidity. To solve such problem, it is necessary to conduct experimental study of the stage and timing of the dry process of apricot product products in a direct solar dry with natural convection. Selected apricots were also proceeded using traditional method before being placed in a solar dryer. The dimension of the elements of the structural model of a direct acting solar dryer with a natural convection were selected, primarily based on the following method proposed by the author of the work. The schematic and general view of direct solar dryer with a natural convection is given in that figure. The solar radiation directly falls on the device relatively to horizon is about 38 degrees, 38 degree, 38 degree and 52 degree, taking into account geographical with region. The total length of the device is about 2.5 meter with 1.55 meter. The length of the height of the each chamber uh, is about 0.75 meter. Height of the second chamber is about 0.4 meter. A general view of the direct solar dry, as I have mentioned, is given in the figure 1. Experimental setup. The indirect solar dry is a natural convection. General view of the device is given in the figure 2A, and schematic diagram of the device is given in the figure 2B. Each experiment was conducted in triplicate to ensure the repeatability. Approximately 10 kg of apricot were loaded per trail. In the case of open air dry, fruits were selected on the trays under the direct sunlight, protected from the insect dust with a mesh cover. Based on the analyzed scientific research carried out by scientists around the world using methods for determining the line dimension of solar dry an indirect solar dry with a natural convection was developed. Drying time. Apricots in the direct solar dry require 6 days to reach the equilibrium moisture content, while the indirect solar dry reduced the time to 6 days. In contrast, open air dry required 10 days, as shown higher variability due to the fluctuation weather condition. The product surface temperature in the direct solar dry reached up to 56 degrees C, which caused noticeable hardening of the outer layer. In the indirect solar dry, maximum surface temperature was limited to 42 degrees C, preserving fiber structure and improving the product quality. The drying process of the apricot product was carried out in a direct solar dry with a natural convection. The research results are presented in the figure 1. The stage cycle of the process of the drying apricots in solar dry with a natural convection is given in the figure 3. A, B, and C stage of the wet, hydroscopic and equilibrium stage apricot 1, 2, 3 drying speed of the cycle. 1 and 2 change in the temperature and humidity on the surface of the dried apricot. 3 and 4 change in the temperature and humidity of the drying agent. 5 is the speed of the drying. In the figure 4, stage of the cycle of the apricot drying process in a modernized indirect solar dry with natural convection is provided. A, B, and C stage of the wet, as I have mentioned. Hydroscopic and equilibrium stage apricot. 1 to 3 periods of the drying speed. 1 and 2 temperature of the humidity of the surface of the drying apricot. 3 and 4 temperature of the humidity of the drying agent. 5 is the speed of the drying. In this page of the presentation, we have just give the effect of the silica gel storage cabinet. In the indirect solar dry, silica gel storage cabinet reduced the humidity in the drying environment by 5 to 7% compared to the open air drying. The result is slightly faster in final stage and improved preservation of the color and texture. Sample dryer with the silica gel showed lower residential moisture availability. In conclusion, the drying speed of the apricot product in the direct solar dry with the natural convection decreases sharply from the 2000 multiply 10 10 minus 3 to 20 multiply 10 minus 3 at stage. A and B, while the drying speed in a modernized solar indirect dry with natural convection decreases relatively slowly. It is known that slow drying of the agricultural process has a positive effect on their quality. The classification of the botanical characteristic of the apricot for drying in a indirect solar dry is natural convection and air collector was studied, and changes the humidity of apricot were also studied. In the course of experimental study, drying curves were determined, reflecting the process of drying apricots during, according to the which temperature of the air entering and exiting the dryer changes to 40 to 50 degrees C. Humidity 16 to 35 degrees C. In order to determine the level of the quality of the dried products when conducting experimental in indirect solar dry with natural convection and solar air collector when drying apricot product in this device and the open air at the same time, the amount toxic element was 0.13 milligram over kilogram and 0.22 milligram over kilogram. The amount nitrate ion is a 8.5 milligram over kilogram and 9.3 milligram over kilogram. As a result of which the quality apricot products has improved by average 10 to 12%. The study demonstrated the performance of solar dry varies significantly depends on the design. The upgraded indirect solar dry with natural convection is provided the shortest drying time 5 days, lowest product surface temperature 44 degrees Celsius, and best preservation of the apricot quality compared to the direct and open air dry. The integration of silica gel into the storage cabinet further enhances drying efficiency by lowering the humidity and stabilization final product quality. They offer reduced drying time, improved the product safety, and better nutrition retention. Future research should also focus on scaling the technology for larger application and conducting the detailed energy efficiency analysis.